Dreamworks has given us some revolutionary films, and some good films, and some, creative fan recreations. But no matter how much more content these Pixar plagiarists pop out, there's no denying the extraordinary effort put into each and every movie. So it pains me when they apply incorrect physics to otherwise flawless movies, Monsters vs. Aliens. Every time I see the protagonist, I laugh maniacally at the Godzilla-like structure. During Susan Murphy's transformation into Ginormica, one of two phenomena is happening. Either she is holding the same mass but increases volume, or she gets far too tall for her body to function, crushing her. Possibility number 1 states that sizing up a human will keep their same weight but make their size bigger. This, however, affects their density, and in Susan's case, would result in her being 880 times less dense than air. We also see her thunderous running and crushing gas stations, so we're going to go with phenomenon 2. The mass and volume scale up together. But the problem with this is that human bones have certain points where they can't support any more force, and being the brittle material that they are, they'll either snap or buckle, breaking themselves. Average human femurs can buckle in a laboratory setting with 4,000 newtons, or around 890 pounds, pressing on the top and bottom. And this applies to Ginormica, and a factor known as the square cube law comes into play, stating that the cross-sectional area of objects gets higher much, much slower than its volume does. Say, for example, you had a cube that was 4 meters wide, 4 meters tall, and 4 meters long. What would its volume be? Well, for a cube, just raise the side length to the power of 3, and you have the answer. As far as the cross-sectional area goes, you need to multiply the length and width of it, or square the side length. Say now that you double the size of the cube. You need to multiply each side length by 2, giving you 8 times 8 times 8 for the volume, and 8 times 8 for the cross-sectional area. Which answer is bigger? As you can see, the volume of an object increases much, much faster than the area does. And in the world of physics, volume relates to the force, and area relates to pressure. Meaning that a super heavy human can't necessarily be held up, as the bones may snap under the pressure. And what we can do is use these formulas to find out if Ginormica's legs would buckle under her extreme mass. Dreamworks has confirmed that she grows to be approximately 49 feet 11 inches, and if she was an average sized woman before, then she's around 5'7" and 120 pounds. Converting to metric and popping the numbers into our mass formula, we find that Susan Murphy becomes 39,140 kilograms, or 86,100 pounds. At this point, I'm highly doubting this massive maiden's survival, and the other formula will find the cross-sectional area of her femur. I just want to say that this will be an extremely rough calculation, as strengths and buckling and brittle materials are all a part of a very, 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 very complex and difficult area of engineering known as stress, and what I'm going to be doing may be off a little bit. The calculations I'm making are assuming that all of her mass is crushing down on these two femurs, and that it will crush straight down, covering the whole bone. Anyways, average humans have a femur 4 inches wide, so dividing by 2, squaring it, and multiplying by pi, we have the cross-sectional area of normal Susan's femur, 0.007853982 square meters. Equation filling, we get her giant femur's area, 0.63 square meters. Now the force. Mass times gravity is the force you exert on the Earth, and multiplying the area of one femur by 2, as there are 2 femurs, we can find out how much pressure is on Susan's large femurs. And Ginormica places on her brittle little bones 44.2 pounds every square inch. Holy cow, but will it snap? The point at which a bone will snap, or fail as engineers call it, is known as its ultimate tensile strength. For bone, the material, it's around 18,855 pounds per square inch. Nowhere close to breaking under Ginormica's ginormousness, but we can apply this number and her mass to find out just how small her legs could possibly be before snapping. Rearranging the pressure formula, we're left with area equals force divided by pressure. In this case, the force is Ginormica's earthly pushdown, and the pressure is the ultimate tensile strength of bone. Dividing those and dividing by 2 for each leg, we have numbers. Placing this newfound area into the area of a circle formula, and rearranging for radius, we have the radius, and finally multiplying by 2 gives us the width of one femur. And finally, the moment of truth. Susan Murphy, in giant form, could have thigh bones as little as 4.3 centimeters wide. That's only 1.7 inches. Flabbergasting, astonishing, bewildering, breathtaking, speechlessification-izing. Susan the superhuman indeed. Until next time. Oh, hold up. There are still problems non-physics related. The problem with Ginormica is that she's large, and would need to produce more energy and eat more. Also, we haven't taken into account all the pulled muscles she'd receive, the food she'd need to eat, and how poorly the blood would pump to the rest of her body. Long story short, comparing her to average women and the calories they need to eat per day, she could solve her food issue by consuming approximately 1,530 Big Macs per day. She'd need to burn calories too, but she'd constantly pull muscles trying to exercise, and she'd breathe very, very poorly. Her heart would be overworked to the point of failing, and she'd die. The end. And then there are creatures like Insectosaurus, who are something like 330 feet tall. Bugs have exoskeletons and therefore not really any bones. But think of Insectosaurus like this. Alright, before this video ends, click right here in the top right corner to tell me which kind of theory you enjoy most. These are getting harder and harder to make, and I need to start narrowing down what area is liked most to provide more of that content. Recently I've totally lost my schedule, and I now upload whenever. Hopefully at least once a week, but I can't really promise it. Anyways, until next time, I'm the Theorizer.